let's say we've trained our model and we're pretty happy with its performance and we want to use it for some application later on. It'd be very annoying that every time we want to use this model, we have to retrain it. And with the examples we've seen so far, training time is pretty fast, rather quick. It goes rather quickly. But as our data sets gets larger, we have new features, we're going to use more complicated models. That training time no longer is trivial. It's going to take a while. It'd be very annoying that every time someone's going to use our application that we have to go through the training process. So we have to have a way where we can persist our model. In other words, save it to disk. So let's see this web app I have here for sentiment analysis. And let's say I'm going to say this product is amazing. I don't want every time someone hits submit that it takes the training data, retrains the model, makes a prediction. It'd be very nice where it can just simply load the model, reload the pre-trained model, and use it to make a prediction. So it'd be very quick. It'd be very annoying to have to wait a long time to get the result. So let's talk about this. Let's talk about how we can persist our model. How we can save our model to disk such that we can use it for a later time. Right, there's several ways we can do it. I'm going to show you one common way. So let's go ahead and start. Let's develop a quick model here. Okay, so we're using the California housing data set. We're going to have a very simple workflow here. We're going to scale our features and then pass it into a linear support vector classifier. We'll have some lectures regarding the support vector machines, but just consider it some model that we're going to use to make predictions. So let's just construct a pipeline, very simple pipeline. So pipeline, import pipeline, and then our pipe is just a two-step process. Here we have the scaler, our standard scaler, and followed by the regressor. So let's call that RGR. Here I actually want to import the SVR, that's the regressor. The regressor version of the model, make sure I run that block there. Alright. There we go. So we have our pipe. Let's go ahead and fit. And let's go ahead and print out the results. Score. This R squared value on the training set. Okay. So performance pretty poorly. That's not the point of this exercise. Okay. So let's say for some reason we are happy with this model. Performance pretty poorly, but oh well. Okay. Now let's go ahead and persist this model. Let's go ahead and save it to disk. Let's go ahead and dump it to disk. So one way to do that is we're going to import the DIL library. So DIL is an extension of the Python package called pickle. And as the name implies, pickling in general is a way you can preserve fruits and vegetables, right? You pickle cucumbers and they last a long time. So that's what would be funny here, where we have the pickle module where you can go ahead and pickle Python objects. In other words, we can take a Python object in memory and dump it to disk, such that later on we could unpickle it and retrieve that object, restore that object, and place it back into memory. And dill is simply just another package that's very similar to pickle, but it's supposed to be more robust or has some additional features. So we'll go ahead and use dill, but some people like to use pickle. Let's just use dill. They have a very same interface. All right, so we're going to import dill. So we're going to say, let's open up a file. So with open, I'm going to just call this my model.dill. I want to have write access to this file. Okay, then I say dill.dump, and the first parameter there is the object we want to dump to disk, in this case our pipe, and the file handle f. Okay, let's go ahead and look at that file, my model. There it is. There it is on disk, and we can go ahead and look at some additional features. Okay, there is our model. It's 1.3 kilobytes. Okay, now I'm going to go ahead and clear out my session. So I'm just going to go to kernel and restart and clear output. So now I no longer have my objects in memory. Okay, so if I say pipe, so if I do, let's go ahead and import our data set here. Okay, I'm going to run these two things. Okay, so let's see if I use my model, pipe.score x and y. I got a name error. Pipe is not defined. No problem. Let's go ahead and restore it from disk, load it from disk, say with open, my model. I want read permission on that file, and we're going to do, instead of dill.dump, we're going to do dill.load. So pass the file handle, assign this to a variable called pipe, a name called pipe. So I haven't imported dill. That's what the error message is all about there. Got to make sure I import the relevant packages. So import dill, then I can use dill. So now I have my model back. X and Y. Yep, there you go. Back at that same score. So now I have loaded my model in memory. So that's what's happening when we construct this web app here. We have a dill file for the pre-trained model, and when we create this web app, we load that file in memory. So there's no need to retrain the model every time we have to use it. So feel free to use the dill package to serialize your trained models, to dump them to disk. You can try it out for the mini projects where you don't have to retrain the model every time you want to use it. So you can go ahead and practice with dill and dump your models to disk when you're doing the mini projects. Something I want to also point out here is you can go ahead and use dill along with the gzip library. Some of these models can be very large. You can easily compress those files by using the gzip library. So import gzip. It's a very similar syntax, but instead of open, we're going to use the gzip open, the open function available in the gzip library. Same syntax. Just go ahead and tack a file extension of .gz to tell me that this is a compressed file, and do dill.dump on pipe and f. Okay, let's go ahead and inspect that file. And there it is. So notice it's slightly smaller than before.